Today we're going to look at section 10.2, simplifying radical expressions. Radicals have to do with things like square roots, cube roots, fourth roots, so on. Most of what we're going to do here is talk about square roots. You probably know that the symbol for a square root looks something like this. And we probably know that the square root of 9 is 3, the square root of 25 is 5, and there are many, many others. We're going to see today that you can do things and talk about like the square root of 8, which is not cute. These two are cute because they are perfect squares, so we can easily find the square root. This one, however, is not cute. But we're going to learn how to simplify these expressions using the property of square roots. And, well, we're going to use that, and we're also going to talk about the quotient property. So I think the first thing we need to do is get familiar with the squares. If you don't know what the squares are, then you don't know what you're looking for, and we need to be able to look for and identify perfect squares. So 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. I've asked you to do 1 through 12. 7 square, 8 square, 9 square, 10 square, 11 square, and 12 square. Now, you shouldn't have any trouble knowing most of these. It's just 3 times 3, 4 times, it's a 9, 4 times 4, 5 times 5. So these should be very familiar to you. In fact, from pre-algebra, you probably know all of these anyway. But I'm just wanting to make sure that we are familiar. 9 times 9, 10 times 10, 11 times 11, and 12 times 12. Obviously, we could go further, and sometimes we do have to do the square root of 169, the square root of 196, square root of 225, and so on. But for now, I want to just keep it to these, and if we have something weird or stranger, we can look at it. Because most of the work we do is going to be with these perfect squares. So they tell us here that we can break these things down. We mentioned here about the product property of square root. So we can break these things down. The square root of 36 is 6. That ought to be easy, obvious to us. And so if we can use this to put them together, we can also do that to pull them apart. So let's talk about these problems. None of these are cute. By that I mean 18 is not a square, 27 is not a square, and 32 is not a square. But they can be simplified. Now, we can't do that cute thing we did back up here where we saw that square root of 9 was 3 and the square root of 25 was 5. We're stuck more in the area of this where we have the square root of something that's not a square. So let's go back. So the square root of 18. 18, I was going to talk about 18 for a second. When we did factoring, we saw that the pairs of 18 are 1 and 18, 2 and 9, 3 and 6. Now, why I'm mentioning that is because that's a square and that's a square. So, what we're going to do here is we're going to rewrite 18 as 9 times 2. Why 9 times 2? Because 9 is the square hiding in there. I mentioned that here. When you look at 18, you may not see the 9, but he's there. Now, the square root of 9, this piece here, is 3. And what's left after you take out the square root of 9 is the square root of 2, which is not cute. You can't fix it. And that's the final answer. 3 times the square root of 2. So 18 simplifies to this. So we're looking for the square hiding in there. We look at the next problem, square root of 27. I hope you recognize that 27 can be written as square root, well, 27 itself can be written as 9 times 3. Why 9 times 3? Because 9 is the square hiding in there. And the square root of 9 is 3, and the square root of 3 is the square root of 3. And so this simplifies as this. Finally, we'll look at the square root of 32. Now, the square root of 32 could be written as the square root of 4 times 8, but that's not the best option. 4 is a square, by the way, but it's not the best option. 16 times 2 is the best option because 16 is the largest square hiding in there. If you remember back when we did the 18 earlier, we had 2 squares hiding in there. We went with the largest one. So if you did 32 and you looked at all the factors of 32, 1 and 32, 2 and 16, 3 doesn't work, 4 and 8, you can see you got a square, and a square. And you want the largest one, which happens to be 16. So the square root of 16 is 4, and the square root of 2 is the square root of 2. That's how this is going to work. So the square root of 52. Now, I don't run around every day thinking about all the factors of 52, but I should be able to generate them pretty easily like we did in our factoring chapter. 2 and 26. 3 doesn't work. 4 and 13. And I think that's all. So you can see we have 2 squares hiding in there. One of them, the 1, is always there, and he's of no real help to us. So I'm going to rewrite the square root of 52 as the square root of 4 times 13. Why? Because 4 is the square hiding in there. Square root of 4, square root of 4 is 2, and the square root of 13 is the square root of 13. Done. Square root of 45. Hopefully, you can easily, and if you have to, do the 1 in 45. I mean, if you can see it, then you see it. But if you don't be afraid to take the path. 2 didn't work, 3 does, 4 doesn't work, 5 does. And when we look at that, we got a square here and a square here. And so we can see to rewrite the 45 as 9 times 5. And we get the square root of 9 is 3, and the square root of 5 is the square root of 5, making the answer B. Now, if we can pull them apart, then we can put them together. So this one becomes the square root of 48, because 2 times 24 is 48. Now, can I simplify the square root of 48? In other words, is there a square hiding in there? And hopefully, with a little bit of work and finding all the factors of 48, you can see that 48 could be written as 16 times 3. Now, true, it could also be written as 4 times 12. And 4 is a square. It's just not the largest square. Those are all the factors. So you can see square, square, square. You want the largest one. So, square root of 16 is 4, and the square root of 3 is the square root of 3. So that's